Hello everyone! Today we are going to explain thin layer chromatography, also known as TLC, using simple materials and Skittles as an analogy. Thin layer chromatography is a separation technique used in chemistry to separate and identify compounds in a mixture. Even though TLC is commonly performed in laboratories using specialized equipment, the basic concept can still be understood using simple demonstrations. In this video, we will explain the principle of TLC, how separation occurs, the calculation of RF value, and the application of TLC in daily life. First, let us understand the basic concept of TLC.
In this experiment, a small sample of ink from a marker is placed on the baseline. The solvent acts as a mobile phase and moves upward through the stationary phase. Let me show you how it works. The experiment, we will replace the TLC paper with a tissue. So firstly, I will draw a baseline 3 cm from the bottom of the paper. And then I will put 3x mark because we will use 3 colors for this experiment. For the compound, we will use purple, pink and green. I will put each color on each mark. To replace the beaker, we will use a plastic cup with water in it.
Now, let's observe what happens after the experiment begins. As the water moves upward through the paper, it carries the marker ink along with it. At first, the ink appears to move as one spot. However, as it travels higher, the different dyes in the marker begin to separate. This happens because each dye has a different attraction to the water and to the paper. Some dyes are more soluble in the water, so they travel further. Other dyes are more strongly attracted to the paper, so they move more slowly and remain closer to the starting point. As a result, the single black marker spot gradually separates to several different color bands. This is the final result of the separation process. Even though the marker looks like one color, chromatography shows that it is actually made up of different colored dyes.
This is exactly the same principle used in the thin layer chromatography, where each component moves a different distance and from a separate spot. The clearer the separation, the easier it is to identify the different components in the mixture.
Next, we go for the calculation part.
Alright, the separation is done. Now it's time for the math part. Don't worry, it's super simple. We need to calculate what the scientists call the RF value, which stands for retention fact. The separation process complete, the RF value can be calculated.
The formula is RF equals to distance traveled by solute divided by distance traveled by solvent front. Let's look at this quick example. We measure from this starting line at the bottom up to where the blue spot stops. As you can see, it traveled exactly 3 centimeters. And for the water, it kept moving all the way up and stopped at this top line, which is exactly 5 centimeters. So the RF value is calculated as 3 divided by 5. Therefore, our RF value is 0.6.
Different compounds usually produce different values. Scientists can use these values to help identify substance. RF values can also be affected by the type of solvent and stationary phase used.
Now, let's look at how this is used in real life.
Thin layer chromatography is not only used in laboratories, but it also has many applications in our daily life and different industries. For example, TLC can be used to identify unknown compounds. In forensic science, TLC can help analyze ink samples from documents or compare different inks. In pharmaceutical industries, TLC is used to check the purity of medicines and to monitor chemical compounds during production. TLC can also be applied in cosmetic industries to analyze ingredients and ensure product quality.
The advantages of TLC are that it is simple, fast, inexpensive, and also requires a small amount of sample. In conclusion, thin layer chromatography is an important separation technique based on the separation between the stationary phase and mobile phase. Although we use just simple materials in this video, it also helps us to understand the basic concept of separation.